Hello, greetings. This is Michael Schuckers, and this video is for the 2024 Big Data Cup. And I'm just going to talk to you for a little bit here about some thoughts on doing research and doing projects like you'll be doing for the Big Data Cup in hockey analytics. And so I guess on behalf of the Big Data Cup organizing folks, welcome. It's great to have you. We're excited to see what you can create. So let's get started. I'm going to talk about a little bit about some things in terms of observations from what I'm going to call found hockey data. And this is borrowing from an idea from Nick Horton about found data generally. So we've got, we're going to be talking about a statistical mathematical approach. I'm a professor of statistics and data science, St. Lawrence University in Northern New York. And, we're going to be talking about, or, when we think about hockey data, it is a many dimensional process. You can think about each player, their location, right, speeds, all of those sorts of things that you can get from the Big Data Cup data. I'm going to use some NHL examples, but all of the things pass over to hockey tracking data that you're going to be working on for this competition. So we model it, or we try to deal with some of the imbalances that come about because the data is not intentionally collected. So really, one of the things we're trying to do is figure out what causes what, right, in terms of hockey analytics. And, you can think of Sarah Nurse, right? Does Sarah Nurse drive higher expected goals? Expected goals being another term for probability of a goal. We often sum up expected goals over a game or a period or, a season. On the power play, right? Is 4 forwards and 1D yield a better power play? And you can think of better power play in terms of a bunch of different metrics for that outcome. But, relative to, say, traditional 3 forwards and 2D, are we getting better outcomes with 4 forwards and 1D? And then, something else here, carrying the puck into the offensive zone, is that going to lead to a higher Corsi 4 percentage? So using a little acronym here that's somewhat common in hockey analytics, but basically shot attempts for as a percentage for your team as a percentage of the total. And for this year's Big Data Cup, right, you're working with special teams or you're working with zone entries and zone exits. And so some of these outcomes appropriate there. Okay. A lot of this assumes, right, that all else is being equal, right? So when we look at the 4 forwards and 1D, right, we're maybe assuming that the quality of 3 forwards and 2D is the same. When we think about, right, the difference between those two. Is it a difference in the number of forwards, or is it a difference in the players, right? And so if we want to just look at 3 forwards and 1D, we're assuming that all else is equal there. Okay. For down data, that's generally not true. The norm is that things aren't equal, right? The quality of the players is not the same. The quality of players that Sarah Nurse is going to play for, or Sarah Nurse is going to play with, excuse me, is often higher than when she's not on the ice, just because of the quality of player that she is. So something that we've got to be aware of. This is not design data. And so we've got to account for some of these other factors. And so things get to be multidimensional as we try to account for some of these other factors. And I'm going to give you an example in a little bit here, but I do want to talk about sort of choosing your outcome. So, we've been talking about causes and outcomes here. Really, I have been talking about causes and outcomes here. And one of the things that we want is repeatability or reliability. That is, if we see something in the first half of the season, are we seeing it again in the second half? Right. And so one of the things in sports analytics generally is that we think of something as a skill if it's highly repeatable. That is, right, if someone can't do it, right, they have very good season or very bad season one year, and then is that repeatable or are those outcomes repeatable again? The other is that we want outcomes directly related to winning. This is often referred to as validity. And there are lots of ways in which those things can happen. Okay. And so, in terms of repeatability and reliability, right, looking at things across seasons, looking at them first half versus second half of a season. And then some really innovative approaches have split data into alternate periods or alternate shots. Again, right, trying to account for all of those factors that are the same, right? Across seasons, right? The drawback is teams change every year. And so who your teammates are or who your goalie might be is going to change, right? First half, second half, again, you have injuries to players there as the season goes on. And so you may have differences there. Whereas if we split within a period or within events within a particular period, right, you're more likely to have a balanced set in both of your groups. The other thing I should mention, though I haven't got it on the slides here, is that the idea of being able to predict out of sample. So if we fit a model and we try to get some explanatory power out of that model for one data set, we want to make sure that what we're doing is not overfitting, and that really goes to some of this repeatability, right? And not fitting it very, very well to that particular data set, but then if we go to predict it on another data set. And so this data splitting helps a good bit with that. I mentioned outcomes directly related to winning. Obviously, winning a game in hockey is an outcome related to winning, but we tend to prefer micro events. Goals, because there are so few in hockey relative to a sport like basketball, right? Goals is an outcome that we can use if we have large numbers of data, large numbers of games, but if we have a smaller set, we're more limited by using goals. So we often use shots or expected goals. I mentioned expected goals earlier. The acronym XG, they're often used for that. And then Corsi and Fenwick, which are unblocked shot attempts and all shot attempts there, respectively. And again, right, we are upping our sample size in terms of things that we know that can be related to winning. So we know that a team's percentage of Corsi events in the first half is related to how they win in the second half of a season. And so these things are viable outcomes when we're looking at doing some hockey research on the sorts of effects that you're going to be looking at, right? Zone entries, zone exits, power play, and penalty kill. Okay, the idea here, right? We think of this cause and outcome, but there's always the possibility that there's some other factor, right? And in statistics, we call that a confounder. And so one of the things in terms of doing research is to be able to look through and think through those confounders, because it's possible that they are leading to, right, the cause and the outcome. So, right, one thought here is, right, players and their Corsi 4 percentage, right? Zone starts are different. So where a player starts their shift in a given situation affects, right, whether they're going to get shots off. So if a player is spending a lot of time starting in the offensive zone, then they're going to get more shots just by virtue of they're not having to work as hard, right, to bring the puck into the offensive zone and therefore to get shot attempts. Your quality of your teammates does the same thing, right? If I'm playing with Sidney Crosby, if I'm playing with Nathan McKinnon, if I'm playing with Connor McDavid, right, then I'm more likely to do well in terms of my shot attempts, right? So those sorts of things, right? I'm playing with Sarah Nurse. Those sorts of things are things that we want to try and account for. And there are statistical methods, primarily of sort of the regression family or the classification family of models that allow us to do some of that adjustment. Okay, so a little illustration here. I realized that I put wild illustration. It is not meant to be the Minnesota Wild here, But making up a somewhat silly example to sort of illustrate this idea of possible confounders, we're going to study goalie behavior in the trapezoid, right? So we've got some tracking data like you've got for the Big Data Cup, right? Every time the goalie is in the trapezoid, they have a choice. They can play the puck or they can leave it for the D, right? And so, the question is, if I pick an outcome, right, as to whether a zone entry was successful based upon that goalie choice, right? I can get some measure of the decision making for a goalie. Okay. And so, yeah, play the puck in the trapezoid. Does that lead to a higher zone entry percentage? All right. So here's my first example, right? We're going to take Aiden Hill from Vegas, right? And the choices: I can play the puck in the trapezoid, or I can leave it, right? I can leave it for Martinez. I can leave it for Pietrangelo. I can leave it for McNabb, Shea Theodore, Nick Hague, right? Zach Whitecloud, right? So Aiden Hill's got a bunch of choices there, right? And they might make different choices depending upon, right, who is the D that they're leaving the puck for. By the way, I'm pulling this here late February from dailyfaceoff.com in terms of the players that are healthy. Shea Theodore being on my fantasy team, I know that Theodore's healthy again. So back in the lineup there. Alternatively, right, we can think of Kakkonen in San Jose and their choices, right? They can play the puck in the trapezoid, right? Or they can leave it for Ferraro, for Emberson, for Thrun, for Ruda, for Okachuk, right? Or Burrows, right? Those are maybe some less good choices that they have in terms of who the puck leaves for. I think we could generally say, right, that their sort of average quality of D in Vegas is going to be higher than it is in San Jose. And I do note, don't send me emails, don't tweet at me, right? Vlasic is currently out of the lineup, right? Vlasic being a quality D here, certainly first or second pairing, I think, in San Jose among this group. So the big picture here is, if we were going to assess the behavior of Kakkonen or the behavior of Hill in terms of, right, their decision making and how it leads to zone entry, we're going to have to account for the players that they're leaving it for. And there are methods, and not time in this video, but certainly we've got time, and you can look up and research some of the statistical methods that go into that. I'll highlight some of the work that's gone on by Brian McDonald and others in terms of right, ineffective math. So Micah Blake McCurdy, the Evolving Wild twins there, in terms of some of their methods that are accounting for players in this sort of scenario, this sort of somewhat silly scenario. I'm not convinced that playing the puck in the trapezoid very much is going to have an impact, but I think it does illustrate the sorts of things that we have to think about as we're going through. Okay. So a little bit here, right? In a non-found data world, if we had, right, statistical design, right, every player, or excuse me, every goalie would play the puck or leave in the same sort of ratio, right? We do equal ratios with every combinations of players, every opponent, and we might do this in some random order. That's a nice theoretical world, but there is, I'll just highlight, right, there is a whole area of research on statistical design. And I think that there are some teams, some hockey teams, that do think about these sorts of things and try a lot of different combinations early in the season to get a handle on the sorts of things that work. Okay. So this is, right, impact of teammates, possibly unequal here, right? Certainly better account for teammates as part of sort of what my analysis. And again, I mentioned why we have regression and other statistical models. Okay. So little summary here. You're going to be working for the Big Data Cup in terms of zone entry, zone exits, and special teams. You want to think about the causes, right? What are the things that are driving them? What are the things that you can observe? And you think about alternatives and possible confounders, right? Things that are maybe affecting both what you think is the cause and what you think is the outcome. Check the reliability and the validity of those sorts of things. The other thing I want to point out, I didn't put it on the slides, but I think it is worth mentioning, is that if we find something, right, that is not causing, right, that is not leading to a differential in our outcome, that's often good information, right? That is things that we don't need to study again in the future, we maybe don't need to pay attention to. And those are sometimes called negative outcomes in research, but really they are valuable. And I think the research community valuing them more and more, right? Because the more of those we know that are out there, right? We don't have people going and saying, oh yeah, I want to study this because someone else has studied it and found there was nothing. So there you go. The other thing is, I would recommend, right, have fun. This is a fun data set. This is a fun project that you've got with the Big Data Cup. And so do that and then tell your story. And I think you're going to hear some videos or a video from my colleague, Allison Lucan, who is just tremendous in terms of telling stories with data and about data. And so with that, I will say thank you. There is my email. I'm also on Twitter at SchuckersM. Again, SCHUCKERS. But happy to answer any questions and looking forward to all of your submissions. Thanks.